So recently I was working on a project that required me to pass functions around, add what methods each object has during runtime, and change a lot of things, which of course I could do with a lot of if checks and create a very ugly code. But it would have been much easier if functions were treated as first-class objects in Java. Being treated as a first-class objects on a very basic level means that you can source, save it, pass it as a method, return it from a method, which, to the best of my knowledge, Python and JavaScript allow, which are two languages I'm familiar with. I know that a lot of other languages allow it, but it's the two languages I've worked with. However, I had already set out to work with Java for this project, so I had to find a workaround, and it was actually kind of fun. So here's what my solutions were sort of for this problem. At the very basic level, there's two ways you can go about it. You can either use lambda expressions, which is, I think, the more obvious one, and it has its certain benefits and drawbacks. And the other one is probably a bit slower, a bit less optimized, but allows for huge customization. And that is dynamically recompiling a class and adding methods on the fly. And it's really nice, but it's the worst solution. So let's go with things one by one. So first I have an interface setup. So for example, demo function, it's an interface that requires you to specify 3 templates. So it will take TCR. T is the object type of the first parameter, C of the second parameter, and R is what you're returning. And based on that, I create a lambda expression. You can sort of read how you can make lambda expressions and how you can sort of save them in interfaces. So here what I have is a demo function that I generate from a method. So this is how you can return functions from a method. And what generate basically does is it creates a function, SMP, that will take 2 parameters, and then based on what I have input into the method generate. So what it will do is it will create a string. It would add the first parameter A times to the string. Then it would add B times spaces. So how many spaces is specified by B. And then it would add C times the second parameter to the string. So if I have specified 2, it would add parameter 2 and parameter 2 concatenated in the string. And then if parameter length is greater than 3, so if what I've specified here is greater than 3, it would add D to the output. And if the parameter length is greater than D, it would once again concatenate parameter 2 to the output and it will return the output. And then at the end, so I think this would be easier to see, in the end I return the function from the method. So let's see what this function does. So here is a small example. You call the execute. So this basically sort of runs the function. What it does is just it calls the interface execute method. It's an anonymous function saved into an interface, and if you do more than one method specified interface, it sort of gets buggy. Maybe there's a workaround for it, but I didn't look into that because this was sufficient for my case. So if you run this with the input of hi and world, what it would output, and it might take some time to compile as I am recording. So it would put 2 times hi. So because we specify 2, so 2 times hi, 1 space bar. That is correct. Then 1 times the word world. Okay, but we have 2 worlds. Why is that the case? Well, it is because we have specified here, if you remember, that if bar length is greater than 3, so hi is more than 3 characters, it would concatenate D, which was not the case. So it did not add 3 after the first world, but world had more characters than 3, therefore it concatenates another world at the end. So let's see what happens if I input a different parameter. Would the output change? So yeah, I input hello there, and let's see what that does to the output. So it would put 2 times hello. Well, that's correct. 1 times spacebar, and then 1 times C. 1 times there, which is true. And this time the 3 is concatenated, as hello is greater than 3 characters. And then it would, if there is more characters than 3, it would concatenate there as well, which it did. So that's the very basic way you can work with this. Just to show you that you can create from the same method, you can return different functions. So if you generate input 10 0 C35, and I think just for the for this example, I'll uncomment this so you can see that it will do two different things. So as you remember, hi, world will be outputted, and then it would output 10 times hello, 0 space bars, 3 times there, and then it would append 5, and since there is exactly 5 characters, it would not add another there after 5. So as you can see, it sort of saves whatever you input here into the function, and it becomes constants, which is quite nice. It kind of works like in JavaScript, where if you create a function that outputs a function and you input some things in the outer function, they would sort of become like constants in the inner function. As for a more third example, so this is a function that returns a function. So what generate2 does, it creates, let's find it. Yeah. So what generate2 does is it creates a function that returns itself a function. So as you can see, the return parameter is a demo function. So this is a method that returns a function that returns a function. Therefore, to run it, as is the case in here, you have to execute twice. So the first time you execute it, these parameters won't do anything since we didn't specify what to do with them, but it will just act as if you called generate with the parameters a and b input here and 1 and 2. And let's see that. So as you can see, you have to execute once, and then you have to execute twice, because the first time you just get a lambda expression. So as you can see, it would output as a many times. So let's just, for an easier example, put a here, so you can sort of see the difference between the two. Sorry about the load. So as you can see, it's different. If you remove the second execute and just leave it like that, since you just get a lambda expression and that's not executed, you sort of just will return, yeah, this is a lambda expression and the hash code of it. And then you can do some more interesting things. I call it complex functions this time, but it's basically the same thing as the demo function. Where is it? There you go. So instead of having, the parameters, I just input an array of objects as a parameter of the function. And let's see what I do here. I specify add, which is a complex function. It will take one parameter. And then it will just be adding all the integers that I input in there. So as you can see, I created an integer array of 5, 10, 3, 5, which sums to 27. And let's see if that's our output. If we execute with this array here, yep, it does output 27. So if we change something, say we add 1 to this number, it should output 28. If my high school math is correct, well, actually primary school math is correct, yes, it does output 28. Going even further, is what I have created here is a dynamic class. So this is a class to which you can add dynamically methods. The way I did it is I actually, application is giving me, well, we'll deal with this in a second. So dynamic class, what you have in here is a hash map that maps a string to a complex function. And what you do is when you get, so basically as you would normally run a method, is you would either call it, if it's a static method, you will do the class name dot and then the method name. So it's sort of similar, except you just, call your instance of your dynamic class, and then you just get, and you input here the name of your function, and then here you can put your parameters in the execute part. Yeah, I see what's telling me that I'm doing something wrong. It's because I'm using the same array for the example. So what I'm doing here is in methods on declaration, in the dynamic class, I add, which is just what we saw before. It adds all the parameters we put in here. And then I also added print, which what it does, it will print the return of everything that we just put in. So in this case, what it will do is, since we are calling the print and then we are executing it, and inside it we are putting another function. So what we're doing here is we're passing a function as a parameter to a function. So we're getting complex function, we execute it, and we put a single array function in there, which is add. And what it will do in this case is, if it's an instance of integer, it will just print the integer, and if it's a complex function, it will just execute the complex function with an array of 5 and 5. So let's see if that's the case. and it did 2828. Yes, because I did not input a complex function here. What I input is the result of a complex function. But as you can see, you can, if you remove the execute, so as to pass a function, not the result of it, I'm not too sure what will happen, as I did not write it down. But yeah, it will output 10 because it just summed 5 and 5. So yeah, that's the essence of it. Now, going into something more interesting, which is dynamically recompiling classes, it's something relatively new for me, and it took me a bit of experimentation. I'd like to thank Tutorials Jacob. Check them out, they're in the description. I kind of got their custom loader class from them. I made some modifications to it myself and some other modifications here and there, but it was because of them that I could do this. So the idea is you have a class, and here down here, I recompile that class. So I have this method get, which will return to me a changing class. Changing class is an interface, and changing class instance, or shortened to inst, implements changing class. This is so that you can have, you can, I think it was the Liskov principle, where you can, wherever you can put the child, you can also put the parent. This is because you keep recompiling changing class instant, so you need changing class inst to sort of work with this. So in here you kind of specify that changing class instant has to have the methods calc and that takes 2 integers, and calc that takes an array of int. You mandate it because it's an interface. So what we do here is we create changing class instance once, and we call the method get. So what this will do is it will recompile changing class. It will save the output in here, and then we load this. Now it was .java before, now it's .class. So it is now in its binary format, and we just call the custom class loader from the tutorial Jenkov to interpret this class for us, and we return a object of instance changing class. So let's see what happens if we run this. Now this is from the dynamic class that we loaded before. Now it tells us to go into changing class instance and make some modifications. So let's go and do that. We're gonna call the calc method, so change return before pressing enter. So instead of adding 10 to the output, let's add 155. Remember to save it, and we can go back in here, press enter, and as you can see, what this does is it creates an instance of the changing class, and then it creates another instance after we saved the file and modified it, and then it would call the calc function inside of it with 4 and 5, and again 4 and 5, the same parameters yielding different results. Because we changed during runtime the value that is added to A and B, and you can check the methods if it's correct. Just not lying. You can also check the GitHub down below. When it gets most interesting is that when you compile the classes, they do not need to match. Now the problem is, since we are sort of forcing it to become a changing class here, we can only call methods that are in changing class, and those methods will for sure be in changing class instance. However, you can use the method class to invoke methods from your instances. So what I've done here is, let's run this. Right, so the first instance has been added to the heap, and now if we go in here, you can see that no such method polls existed when this method was run. So once we uncomment it, so here is the idea. So inst1 does not have this method polls that we added to instant2, and we can remove, we can even uncomment poll if we want. Same result will happen. So let's save this. Remember to save, and then pressing enter. As you can see, invoking the method poll yields he as it should, and invoking the method hello, polls outputs hello to the console. If you want, I recommend making them static, so you can run them with a no reference object. You can invoke them with a no reference object, and what you can do here is really interesting, since you can make custom files that are of the same type. You can change changing class instant to whatever you want, and then with the method invoke, call each function, and that way, let's say you have a chess piece that has custom rules, and you want each chess piece to be a chess piece, object of type chess piece. However, you want it to have different methods, different properties. You can recompile this Java file and add it during runtime, and then just invoke its methods like this. You can do a lot of really cool things with this. And it's quite interesting, I'd say. Last but not least is example 7, which is I kind of used what was until example, let's say 5, to make sort of like a interpreter. So it just, we have the executor class. So this is basically where all the logic is. It has some functions, and you can add functions to it, execute functions. Let me just show you instead of explaining lengthily. There is certain syntax to which I have to stick to, which I have explained in the README file on GitHub. So for example, if I specify add 3 and 4 and 5, well, it's not going to do anything since it just added them, which I have to specify print. So print one time, the result of add 4 and 5. It's going to output 9. You can do print 4 times the output of the addition of 2 and 2, and the addition of 3 and 4, which is 4, 2 plus 2 is 4, 3 plus 4 is 7, 4 times 11, it will output 4 times 11. That's correct. And what is more interesting, you can define functions. So let's define a simple one that it's just going to be 3, which is going to be the addition of 1 and 2. And now let's print 1 times 3, and we'll just give us 3 since this is just the outcome of adding 1 and 2. What is more interesting, you can save executable functions, which are defined here. What it's going to do, let's open the generate. So if you have to specify 2 parameters to it, so let's again define a function. Let's call it this time mod. You have to specify the exe. So you have to specify 2 integer parameters to it. And the first parameter is how many times the second parameter is going to be run, which I know is a bit confusing. And the second parameter is just something you add at the end to your return value. So let's say 3, 4. Okay. And now let's do mod 1 and then print 2, 3. So what we'll do, this will print 3 times. What this will do is we'll run 3 times print 2, 3. So it's going to output 6 3s. Since print 2, 3 means output twice the number 3. And since we specified run whatever we put as the second parameter 3 times, it's going to output 6. And you can do it with any function. So we can do mod 2 add 3, 4. And since we didn't print it, it's not going to print anything. So let's do this. Add 3, 4. Let's check the math just to be sure. So we're adding 2 to the end, and 3 plus 4 is 7. 7 times 3 is 21. And my math seems off. No, my bad, sorry. So it will output 27 because what it does is it adds 3 and 4 3 times. So this will become 7. And then it would add, so it will become 21, since 7 times 3 is 21. Then it would add 2, becoming 23. And it would finally add 4 because of this. And this will result in 27. You can check how this function works in the GitHub. I hope this was helpful for you, and it was really fun to make. I don't see really applications for it. Maybe you can sort of make, dynamic user files, each user having different properties, different methods that other users might not have, different parameters. But yeah, this is not meant to be an interpreter. It is full of bugs, and I'm very well aware of it, as I've specified here. For example, if you concatenate too many functions, it's going to mess up. So if you do add 3, add 2, 2, add 2, 1. Oh, I didn't print it because, yeah, now when we print it, it's going to give a completely incorrect result. The result of this is actually it's 12. Well, sometimes it messes up, not always. But yeah, it's very buggy. It's not meant to be an interpreter. It's just sort of a way to show how you can add methods dynamically to functions with the hash map. And thank you for watching. More devlogs to come soon. Check out my GitHub if you're interested in getting the code and seeing future developments. And see you around.